In today's lesson, we will be talking about graphing cubic functions. So let's look at the parent function f of x equals x to the power 3. Now, to be able to graph this, let's think of a couple of x values, plug them in the function, and find the y value corresponding to that x value. So I'm going to start in order from -2, -1, 0, 1, and then 2. Now, if you plug in -2 in there, in the function, -2 to the power 3 would be a -8. -1 to the power 3 would be a -1. 0 to the power 3 would be a 0, and so on. Now, after finding those points, let's plot them and see what kind of graph you will get. -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Now, this is a cubic function that goes like that. It's increasing function all the way Now, as you can see, the domain is all real numbers because this continues on forever and down forever. So domain is going to be all real numbers, and the range is going to be all real numbers as well. Now, if you look closely at this graph, you will see that there's a point of symmetry at 0, 0 in this case. So the point of symmetry is 0, 0. The origin in this case, in the parent function case. Okay? Now, as x tends to infinity, so we have to look at the utmost right of the graph. So as this is going to the right, it's also going up. So as x tends to infinity, f of x also tends to plus infinity. Now, as x tends to negative infinity, so let's look at the utmost left of this graph. As this is going to the left, it's going down. So down means negative infinity. Now, what are the zeros of this function? As you can see, it cuts the x-axis at the origin, 1 point. So the 0 in this case is 0, 0. Or the root in this case is 0, 0. Now, they're asking me whether this is an even and odd function, or maybe neither of these two functions. Now, in order to decide, you can look at this in two ways. You can either look at it algebraically, or you can look at it graphically. Now, is this function symmetrical with respect to the origin? Does it have a point of symmetry at the origin? And the answer is yes. So yes, it is an odd function. So odd functions are functions that have the origin, 0, 0, as the point of symmetry. Now, to prove this algebraically, let's find f of x and f of negative x. F of x is x to the power 3 as it is. Now, f of negative x, it means I have to plug in negative x instead of x and raise it to the third power. Now, when you raise a negative number to the third power, it stays negative. To any odd power, basically, it stays negative. Now, as you can see in this case, the f of negative x, which is negative x to the third power, is equal to the negative of f of x. So if you multiply the f of x by negative, so negative x to the third, it would be equal to that. So algebraically, we just proved that this is an odd function. So the parent cubic function is an odd function, having the origin as the point of symmetry. Okay? So what is an even function then? Even functions are symmetrical about the y-axis. Can you think of any function that is symmetrical about the y-axis? Remember quadratic functions, parabolas, x to the power 2 or 2x to the power 2. Basically, any function having the y-axis as the axis of symmetry. Okay? So in this case, any function, for example, 2x squared plus 1, which is basically raised up 1. So it still is it's a parabola that's on the y-axis, having the vertex on the y-axis, so it has the y-axis as the axis of symmetry. That would be an even function. So now, Let's try to graph x to the power 4 and see if this is going to be an even function or not. Okay? Again, let's plug in some numbers and see what happens. So I'm going to start with -1, let's say, -2, -1, 0, 1, and 2. If you raise -2 to the 4th power, it will be 16. It's not going to fit on our graph, but oh well. -1 to the 4th power is just 1, 0, 1, and 16. So I'm going to graph the ones that I can graph, which are basically 0, 0, -1, 1, and 1, 1. Now, the only difference between x to the power 2 and x to the power 4 is that when you graph a quadratic, which is x to the power 2, it will go through the vertex and go up. There will be a parabola. But the x to the power 4, it's also a parabola, but it's going to be a flatter, it will be like flat on the vertex. So try to have a flatter vertex and then it goes up. So that's x to the power 4. As you can see, it has the y-axis as the axis of symmetry. So yes, it's an even function. Now, can you think of odd functions that have the origin as the point of symmetry? So we just realized that the cubic function is an odd function. So any cubic function that goes through the origin would be an odd function. But it's only x to the power 3. What else could be an odd function as well? Maybe any odd function that has a vertical stretch or a vertical compression, for example, x to the power 3, 2x to the power 3, maybe 3x to the power 3. So all of these functions are going to still go through the origin, but they're either going to be wider or narrower, like we learned before, with a vertical compression or a vertical stretch. And even if it's reflected over the x-axis, so even negatives would work too. Okay, so I'm going to graph -x to the power 3 with you. So basically any odd function that has a stretch or a compression, a vertical stretch or a compression, that goes and it's still going through the origin, not shifted up or down, because once it's shifted to the right or left, then the origin or the point of symmetry is going to change. It's not going to be the origin anymore. If it's shifted up or down, again, the point of symmetry will be different from the origin. So you want an odd function that would have the origin as the point of symmetry. And let's graph -x to the 3rd and see what happens. So if you plot in -2, so -2 to the 3rd power is -8, times a negative, that becomes a +8. So -1, let's try those. Okay. Now, -1 to the 3rd power is -1 times a negative, that would be a positive. And then you plug in the other numbers and this is what you get. Now remember, you are not allowed a calculator on this lesson. Now let's plot those points. And I will get a 0, 0, a 1 and -1, 2 and -8, -1, 1, and 2, 8, or -2, 8, okay? This is a 9. And now let's connect them. It's going to be an increasing function. Try to be a little bit flat over there at the origin, okay? So this is an increasing function having the point of symmetry at the origin. But how is it different from x to the 3rd? The x to the 3rd would be something like that. So this is basically reflected over the x-axis. Okay? So that is an odd function. Now this is the video. This video covers the parent cubic function, what even and odd functions mean, and an example of each. Now the second video will be covering how to graph transformed functions, transformed odd functions.